This is example 4 of the AEC practice test. And I'm trying to fix this. Oh well, that's alright. I'm going to show a little bit over here. Alright, what it is actually to do is to find the magnitude and direction of the resultant of the four forces shown. So here are your four forces. You have FA, FB, FC, and FD. So we're going to go straight ahead to getting the resultants. So we're going to start with A. Well, actually, we'll just start down here. I don't know what happened there. There we go. So you go FA in the X direction. We're going to say FA in the Y direction. And do the same for each. FCX, FDX. Let's make that a capital D. FBY, FCY, and then FDY. And there you go. So instead of kind of writing it out, I'm going to do the first one, and then you'll see how I do the next ones. So we want to get the, let's change colors here. Let's go with red. Let's go with the yellow-ish. So anyways, we'll start with FA. As you can see, it's going to have a negative X component and then a positive Y component. And then we go up here, so this you have, of course, FAY, and this is FAX. You can't really see that, but oh well. And then we want to look at it. You're going to, obviously, you know the angle, so you're going to have sine and then cosine. It's going to give you that. So we'll start off with sine. Sine of theta equals, so it's O. And then when you look at it again, you say, put in your, fill in your variables. You have sine of 45 equals opposite, which is going to be FAY, over your hypotenuse, which you know, which is FA. So it's 250 pounds. Then once again, you multiply each side by 250. Multiply this by 250. This crosses out. So you're going to get FAY equals that. So I'm going to go back to white and put it down here. FAY equals 250 pounds sine 45 degrees. And that equals 250 sine 45, 176.8, let's call it 6.8 lbs. Alright, and that, as we can see, is that. We go with the same thing, and let's say, let's skip this little test, this exercise right here, multiplying it over here. We know the hypotenuse is going to be right here, and then it's going to be cosine of 45 to get FAX. Oh, shoot, that was FAY. I did it the wrong place. Let's go ahead and put it over here. 250 pounds sine 45 equals 176.8. Let's look at the, it is positive. So we're going to go ahead and erase this garbage right here. And we'll put it over here. So we know this is going to be hypotenuse times cosine, since it's the adjacent leg, the angle. So the hypotenuse, once again, is going to be 250. It's going to be the cosine of 45 degrees equals, it's going to be 176.8 pounds. Again, because it's a 45 degree angle. This equals this, and that hopefully is intuitive to you. If not, that's okay. It will be intuitive if you deal with geometry for a long time. And in the same way, we can kind of go through everything else, as opposed to, writing SOHCAHTOA, which you have to at the beginning. You write sine theta equals opposite over hypotenuse, which is SOH, S-O-H. And if it's cosine, it's ca. Let's see, cosine theta. So that's your ca. So ca and toe is the same thing. It's tangent Let's make it a little squiggly. Tangent of theta equals TOA. So it's TOA, TOA. Alright, you get that, and I should probably stop explaining it by now, but oh well, I still did it. So we're going to go quick here. You have F, we know the angle, so you're going to have, let's go back to red, I guess. You know the angle, you're going to have positive and positive. And I'm going back because I forgot to do negative x. Which one of those things is very important. You're going to get yourself screwed up. So it's always a good thing to go back and check that stuff. But anyways, back to this. Your opposite is going to be FBY. So sine is going to be FBY. You do hypotenuse, sine of your angle, which is 60. And then you have this opposite over here. So it's going to be, we did sine, it's going to be cosine. Cosine is 60. And this the same thing is effectively, sorry, you could do this FAY and this FAX of this angle, which is, if that's 90 degrees, this is going to be 30. And you're like, oh, well, that's going to give you a wrong answer. You might think that, or you're like, oh, that's going to give you the same answer, which it is going to give you the same answer. Because the sine of this angle equals the cosine of this angle. Yeah, that's trigonometry, and hopefully you know that by now. If not, once again, go to Khan Academy. It'll help you out substantially. Okay, FAC, you have x direction. Oh, we're both positive there, so we're good. Oh, we have to actually calculate it. 200 cosine of 60 is 100. And then 200 sine of 60, 173.2. 173.2 pounds. Alright, moving right along. Right here, your FCX is going to be 0. And it's 100% in the x direction. Yeah, that's not right. Your y is 0. Y is 0. Your x is 300. And we're done with that. Going to D. You do the same thing. Let's switch color real quick to make it a little bit more clear. You're going to have negative y, negative x. They're both negative. I'm going to go ahead and throw it out there so I just know. Negative, negative. And what are we doing? It's the same thing. You have your angle, so you know you're going to be working with. And if this is 45, this is 45. 90 minus 45 is 45. So the opposite is right here. Well, it doesn't matter. Opposite of equation is both 45, so we're just going to do 150. The hypotenuse times the sine or cosine is going to be the same. So we say 150 sine 45, and we know this is going to be the same on both sides, but it is negative, since we have negative right there, 106.1 pounds. Once again, it's going to be the same over here, 106.1. I'm not going to do the exercise because we just know that. Let me say, okay, your force resultant in the x direction equals what? And your force resultant in the y direction equals what? I'm going to do the quick math. Math is 176. I think that's 100, 300, and then minus 106.1. Hi, Liam. 117. So this one's 117.1 pounds. And this one over here is 243.9 pounds. So those are resultants. And they are both positive. So when you have your resultant, here's your, you're going to have 117. There you go. Let's make a little arrow. And then 243. And of course, that's actually, they're both acting through this point. Maybe that's confusing. It's essentially like this. You know, but when you add these together, it's the parallelogram rule, or whatever it's called, and you get that resultant. So sometimes I put it like this, and it might be confusing for you, but they're all acting through this point. All the forces are acting through this point. So that's 117.1. This is 243.9. And once again, how do you get this? Your force resultant, you do the Pythagorean theorem, which is Fr equals the square root of F resultant in the x direction squared plus resultant in the y direction squared. And when you do this, let's look here. 117.1 squared plus 243.9 squared 1/2. And you don't really need to do this right here. That's algebra, PIMDOS, I think we learned in elementary school, where you do the parentheses first. But and that I sometimes I put pounds in there, and that helps separate it because I put it up high. If you'll notice, I put up pounds up high and your units up high to keep it away from that. It just helps me out. So sometimes I'll put pound. I was planning on putting pounds in there and then putting a parentheses around it, so it kind of separated that from the squared. But you don't need to do that. Obviously, I didn't even use any units right here because we know it's pounds. But typically, you should keep your units. It just makes for cleaner calcs, and you're going to catch a lot of stupid mistakes. So I got force resultant after working this equals 270.6 pounds. I'm kind of writing diagonal, I don't know why. And I'm looking, where is it? Oh, and they say the resultant is 270 pounds. We got 270.6, and I'm guessing ours is a little bit more. We carried one sig fig, and he probably didn't carry any, which I'm looking at it, and that's correct. So there's your answer, and hopefully by now you've kind of got the hang of this, of finding the resultant. So he's going to move on to something else, I think moments and stuff like that. And I'm going to do some videos on how this loading comes about, and maybe I can, you know what, I've got a couple minutes now, I'm just going to go do it. And if you don't want to listen to it, well, that's okay. Just ignore it. I'm going to get a clean sheet real quick. And there's my clean sheet. Okay. So they're saying these forces, and a force equals mass times acceleration. This is Newton stuff. This is where you're going to learn Physics 1. Force, and then m equals mass, and then a equals acceleration. Yeah, blah blah blah. My spelling's horrible, I don't have time. A acceleration would equal, typically when you're dealing with this stuff, is going to equal gravity. And then mass is whatever it is. We don't really deal with it. Typically we just deal with the weight. And that's what this equals to weight. When you have gravity, when gravity is your acceleration, then the force is your weight. Alright, so this is a point load. This is a distributed load. Or let's call it a line load. I'm sorry, I don't call it a distributed load. And this unit is going to be pounds or kips. Kips being 1,000 pounds. This is going to be, and this is obviously the English, pounds per foot, or PLF equals pounds per linear feet, and then kips per linear foot, or kips per foot. That's what this is. And then you're going to have your distributed load on, let's call it, and I'll do it in 3D here. For instance, if you have you'll see it like this, kind of. What it is just a square footage load. If you have anything saying, oh, it weighs this much. So if you have that many square foot, you'll put it over the whole plate. Sorry, Liam's screaming. So, and this unit is, and I'm thinking you get this, and if you don't, I can do more, or kips per foot squared, or you just KSF, it's kips per square feet, or K. You can even KSI. You can have K